Hello everyone, in this very video we are going to be continuing volume flow rate of a liquid, but in this video we are focusing on continuity equation and the Bernoullis equation. Now we see here the continuity equation actually states that the volume flow rate at one end of a pipe is equal to the volume flow rate at the other end of a pipe. That means if you have a pipe that is uneven this way, is saying that the area here, if we call the area here A1 and the velocity of the liquid here V1, and we call the area of this end of the pipe A2, the velocity V2, then it means that A1 V1 is equal to A2 V2. Remember, from our previous video, we saw that AV is a flow rate, volume flow rate of a liquid. So that means the volume flow rate is equal at both ends of a pipe. Okay, so we see an example here, a question. The velocity of glycerine in a 5 centimeter diameter pipe is 1.6 meter per second. Find the velocity in a 3 diameter pipe which connects with it, both pipe flowing full. Okay, so in this very question, you notice that we are given the diameter of one end of the pipe, and we also given the diameter of the other end of the pipe. So we can actually say that D1 is equal to 5 centimeter and D2 is equal to 3 centimeter. Now, but in our formula, we don't need D. What we want is the area. So we can go ahead to find area, which is exactly what we did here, because area is actually equal to pi d squared over 4. Okay, so that means pi times your d is 5 in this case. In the first case, 5 squared divided by 4, and that is how we got 6.25 pi centimeter square. Okay, that's the same way for A2, the second area, which is pi d squared over 4, which is our area, and that will give us pi times 3 squared over 4, and that's how we got 2.25 pi centimeter squared. Now we did not convert centimeter square to meter square because at the end of the day they will be cancelling each other in the equation. It's a relationship equation, so they will definitely cancel each other. So that leads us back to our formula A1 V1 equal to A2 V2, which is what we have here, and we are looking for the final velocity, which is V2. So making V2 subject of formula is going to be A1 V1 over A2. Now the value for A1 is 6.25. The value for V1, the initial velocity is 1.6 meter per second, which is what we have here. Then the area, the second area is 2.25. So we have 6.25 multiplied by 1.6 divided by 2.25, and that gave us 4.44. Okay, that's not the unit, please. The unit of velocity is meter per seconds. Okay, so and that leads us to Bernoullis equation. And the Bernoullis equation states that for steady flow of a continuous stream of fluid, the sum of the pressure energy, kinetic energy, and potential energy at any point in a stream is equal to the sum of the energies at other points along the stream. Okay, so it means at two ends of a pipe or at two ends of a stream, the sum of the pressure plus kinetic energy factor, potential energy factor is equal to the same thing on the other end. Now, the whole of this equation can be rewritten as this. If we make P1 minus P2 subject of formula, we are going to get this. It's still another way. So your Bernoullis equation can either be written this way or be written this way. It's still the same. Okay, so let's see an example here. We are given water flows steadily through a horizontal pipe of varying cross section. At one place, the pressure is 1.4 times 10 to the power 5. We can call that our P1, 1.4 times 10 to the power 5, okay, Pascal. And the speed 0, that's our V1, which is 0.6 meter per second, 0.6 meter per second. Determine the pressure at another place. We are looking for the P2 pressure at another place in the same pipe where the speed is 9 meter per second. So our V2, which is the speed, is 9 meter per second. Now, if you notice in this question, we are not given anything height. The reason is because the pipe is a horizontal pipe. Whenever pipe is horizontal, it means no pipe, there is no height difference between the two ends of the pipe. So in that case, your H2 minus H1 is 0. And meaning that your pressure depends only on the kinetic energy factor. So you have P1 minus P2 equal to half rho V2 squared minus V1 squared. Okay, so your P1 is 1.4 times 10 to the power 5 minus P2 equal to half times rho